Hey everybody, welcome back to another live stream, whatever this is called, session. Miss seeing you guys. This has been difficult for me as a teacher too, but just excited that at least sort of digitally we can still hang out. If again, there's been a number of you asking about tests and quizzes. If you want to look up and see which quizzes you need, just go ahead and email those to me and I will get you something that you can take at home. And we'll have that done. I want to try to get that done by Wednesday next week. So if you do have stuff to make up, try to let me know as soon as you can which things you need to get done and when you'd like to do them. Because I'm not just going to mail out stuff indefinitely. I got to kind of do it sort of scheduled wise. Okay. I want to start today's lesson. We have a pretty short lesson today, actually. And that is with some homework questions. I know a lot of you were asking me questions about stuff, but again, I want to talk about volume. Remember, volume is how much stuff can fit inside of something. So you could say like how much liquid fits in this cup, whereas surface area is how much paint it would take to cover the outside. So that's kind of what we're looking at there. So let's just remember that, and remember volume is every volume. Okay, all volume is the area of the base times the height. Okay, all of them. Every problem can be reduced to this, with the exception of a sphere, and we're going to talk about that today. But this is the volume of basically everything. Okay, so let's talk about some homework questions. Also remember pyramids and cones yesterday. The only difference with the pyramid and cone is that we threw a 1/3 in there. Remember, a 1/3 is the same as dividing by 3, so don't get tripped up. Remember, fractions are exactly the same as division problems. Whenever you try to make them something else, that's when they get hard. If you remember that they're division problems, it's not too bad. Oh, one other thing before we get started here. I'd really like you guys to take your headphones out unless they're listening to me only. I want you to put your phone on Do Not Disturb and hide it under your bed. A lot of people are asking me for help on stuff, and some people legitimately are confused, and you know who you are. And that's totally fine. I'll never be upset if you're confused, but I will be upset if you're confused because you're not actually paying attention to the video. So put your turn the music off, turn the TV off, go in a room by yourself for 20 minutes. It's not a long video, and give your parents your phone for 20 minutes. They'll think that's amazing. Because in my class, one of the reasons you guys do so well, how many of you, for the first time feel like you're actually doing well in math? One of the big reasons for that is because I don't let you use your phones and I force you to critically think. It's because I don't let you listen to music, because music prevents you from thinking critically, particularly in difficult problems. It's easy if you know how to do it already, fine, put your music on. But when you're learning for the first time, it makes it really, really difficult. In fact, when you're multitasking, essentially it takes your brain from a talented high school student to the level of an 8-year-old. Hi, honey. Yeah, that's a good one. My wife, you want to come say hi after work? Um, so she's taking care of all the people with COVID-19. So, anyways, what she just said is, have you ever been driving, for those of you who drive or your parents drive, and you're driving and you find yourself, you don't know where you're going, so you turn the music down. That's because your brain it instinctively knows that you need silence. You need to take the distractions away. So unless you want to try to do this at the level of an 8-year-old, turn the stuff off. Put your stuff. We're talking 20 minutes. Like, you can do this, okay? And then try your homework for a while. When it's easy, then you can put the music back on. But really, just take the 20 minutes it takes you. It should take you to do the homework. Some people are saying, Mr. Calbeck, I spent 3 hours on this. Turn the music off. Watch the video without distractions. And then if you're still confused, send me an email. Don't ever spend 3 hours on my homework, okay? All right. Now that you have your music off, and we can finish this problem. Okay, so the homework from last night. Some of you guys were having trouble because, for example, let's take a look at question number 5. Okay, question number 5 said, that the pyramid has a square base, and so we can draw a square base. Remember, to draw a pyramid, flatten the base. So we're going to take the square. So instead of it being a square, we're going to flatten it, draw a point somewhere above it, and then connect all the vertices, and you have a pyramid. Okay, and it's perfect every time. So if you're not drawing diagrams as well, please do that. It's really, really helpful. Okay, so we know that the entire volume of this, because remember volume, is the area of the base. I'm just going to put a little subscript there, so remember that, times the height. So let's see what we know. It tells us in question 5, we have a pyramid with a square base has a volume of 120 cubic meters. So that's 120 cubic meters is right here. Okay. We don't know the area of the base, but it also tells me that the height is 10. All right, so we're getting close here. If I want to get a by itself, right now it's being multiplied. I need the opposite of multiplication, which would be, you guessed it, division. Cancels out, divide over here. All right. Oops, sorry. You know what? This is a great one. Remember, because I forgot this most important part right here, 1/3. Sorry, I got distracted because my wife came down, and it tells you what distractions do. Okay, there shouldn't, before we divide, there's a 1/3 here. Sorry about that. Okay, so let's just remember that there. Okay, so I apologize. So we have 12 equals 1 divided by 3 times a. So we want to find a. Right now I have another division problem. So what's the opposite of division? And you guys are all shouting, multiplication. Yeah. When you think about fractions as division problems, they're not that bad. So we multiply both sides by 3. And that cancels out just like the 10 canceled out here, times by 3. So 3 times 12 is 36. So that means that the area of the base is 36. That doesn't tell me the length of one side, though, which was the question. So I have a square. I know that the area is 36. And in a square, remember, all the sides are the same. So base times height are actually the same number. So essentially, base times height is just the same thing twice. So we'll just say base times height, but base and base makes base squared because they're the same number. In fact, the reason we use the word squared to represent an exponent of 2 is because it's the area of a square. So if you want to do the opposite of squaring something, use square root. Sorry. Square root both sides to get 6 equals b. And that's one side length. Okay. I've taught you to think about this as plus or minus 6 because it could be negative or positive, but we can't have a negative distance. That doesn't make sense. So you only have to think about the positive case. All right. And this is the way you're doing all of them. Okay. A lot of these give you the volume first, or you have to find one of these other things. But if you're not starting with how you define volume, then they're going to be really hard. And if you're not paying attention to the videos, then this is going to be even harder. Okay. So, and again, if you're legitimately having trouble, please don't take this as me saying you're bad or something like that, because we all get stuck on math sometimes. It's hard for everybody. But don't let your own distractions make it harder than it needs to be. Okay? Don't make math harder than it should be. We could try another one here. Let's do, how about number 11? Okay, it tells you to find the height of the pyramid. Remember, the volume of a pyramid is 1/3 times the area of the base times the height. So they gave you another square thing here. Okay, or you can use my strategy where you flatten your square out, draw a dot above it, connect all the vertices, and you've got yourself a perfect pyramid as well. Okay, so whichever you like better. This one's prettier because it's got the dashed lines, but it's harder to draw that one. So it tells you in this one that the volume is 15. And it tells you that the base is 3 and 3. So what do you suppose the area of the base is? It looks like this. It's a square with 3 by 3 sides. So the area of the base is 9. So let's plug all that in. So 15 equals 1/3 times 9 times h. Do you think you could find h? Yes, you can find h. This isn't even that tough. 1/3 times 9, that's 3. So here, let me write it over this way. So I now have 15 equals 3 times h. How do you get h by itself? Divide by 3 because it's being multiplied. And h is 5 here too. That's it. All these are the same thing. But it's all comes back to volume. Area of the base times the height. Okay. I'll take a look at one of these other ones from 11.7 as well. So we'll do one more practice problem from the homework. And then we'll learn the new stuff for today. So how about, again, finding the volume's not too bad. Let's do, how about 11? I know that was probably tricky. So we got a cone right here. Tells you that the radius is 3 centimeters. Doesn't tell you the height, and it doesn't tell you the slant height. So we got to figure out what this all is. Dang it. Okay. Got to find the missing dimensions. Okay. So let's see what we have here. Remember the surface area of a, oh, and it tells you the surface area is equal to 75.4 centimeters squared. Okay. So if we want to figure this out here, let's plug it in. So the surface area of a cone is the following. Surface area of a cone is equal to the bottom part, it's the circle, that's pi r squared. It's the same as any other circle, plus pi times the radius times the slant height. So we're going to have to go and figure out what that slant height is. But we already know the radius, so we can plug it in. We also know the surface area. And again, just like last time, we're just going to plug this in and do some algebra. Try not to panic. It's just plugging in the stuff that you know. And you'll get these formulas on the test, which is going to be Friday, I think. I need to double check that schedule, but I think the test is Friday this week. Okay, so the surface area is 75.4. The radius is 3. Notice whenever I substitute in, I use parentheses. Helps you with order of operations. Pi times the radius times the slant height. So if I want to simplify this, a lot of you ask, should I square it or multiply by pi first? Follow PEMDAS whenever you're simplifying. PEMDAS says parentheses, exponents, then multiplication. So I exponent first. So pi times 9 or 9 pi, which you can type into your calculator. Over here, we have 3 pi times L. And this looks like a lot of stuff, but it's actually not. Okay, because pi isn't a variable. You know what it is. It's on your calculator. Remember to use the pi button to be more accurate. And we can literally just type this in and see what we can do here. So here's my equation right now. 9 pi, 9 times pi. That's 28.3 or so. Plus 3 pi. And that's 9.4. So it's 9.4 L. And this is something that they would give you as a hard problem in 6th grade algebra. You got one variable, you have to subtract. Okay? Remember to use your calculator to make this easier. I'm going to subtract 28.3 from both sides. So I have 75.4 minus 28.3. Whoops, I did something wrong here. Hit go to 28.3. There we go. 47.1 equals 9.4 times the slant height. Divide both sides by 9.4. And you end up with about 5. Okay, so the slant height is about 5. Now if I want to find the height, now I've got a triangle. So we're going to go back here. Now I know that the slant height is 5. I just need to find the height, and I have a right triangle here. Okay, and yes, I do expect you to remember all these things that we did this year, like the Pythagorean Theorem. Okay, and I want you to be able to use them. If you don't learn anything else in geometry, learning to critically think is the most important. These formulas you can look up. They don't matter. What matters is being able to think about which tools would be the best things to help you in the situation. So I just think it would be really important for you to be thinking about that. So I actually just cost myself about 2 hours of extra work on my bathroom remodel project because I didn't use the right tool, because I didn't critically think about what would make this easier. So let's go ahead and solve this. 3 squared plus h squared equals 5 squared. A lot of you are going to recognize the answer to this already. 3, 4, 5 is a special right, or it's called a Pythagorean triple. It's a really famous right triangle. And that's what this is going to equal. H is going to be 4. That's just 25. Subtract, you get h squared equals 16. Take the square root, and you get h equals 4. Okay, so that's about as hard as they get on this. But again, I just want you guys to remember all this kind of stuff. Okay, try not to make it harder than it is. Use your calculator, use your formulas. You don't have to memorize this stuff. I'm going to give them to you. The important thing is being able to critically analyze what you got. Okay, let's finish our lesson for today. There's only one shape we haven't talked about, finding surface area or volume for, and that's a sphere. You guys are like, Mr. Calbeck, that's not a sphere. I'm going to teach you how to draw a sphere. You draw a circle, and then you draw a flattened circle in the middle of it. So there's that, and then the other side of the circle, I'm going to make a dashed line. If you really want to make it pretty cool, you can do another one here. And there's your sphere. Okay, a sphere is like a 3-dimensional circle. So if you were to take a circle and just like spin it around itself, that's what it'd be. So it still has a center. It still has a radius to the outside. It's the exact same radius as it would be for the circle. And the equation for the surface area and volume of a sphere is pretty easy. Okay, the surface area, and again, these are the other two equations. I'm not going to tell you why. Okay, so I told you there's going to be 4 equations. I'm not going to explain the surface area of a cone, the surface area of a sphere, the volume of a cone, and the volume of a sphere. Those are the 4 that you're not going to have an explanation for because they require calculus. Though you can get an idea of how they go. I did leave a bonus video over spring break about finding the area of a circle using infinity. That's a similar idea to what you're going to do here, but it's more complicated. So I'm just going to tell you the formula, and again, you'll be able to have this on the test, so don't panic about it. The surface area, so that's the paint that would take to go around the outside of the sphere, is just 4 times the regular area. That's it. It's not weird or strange. I always find it strange that it's exactly 4. It's not about 4. It's exactly 4 times the surface area, or the area of a circle. But that's it. Okay. The volume is even easier. Volume is always measured in cubic units. So how many cubes of water would fit in something? How many cubes of air? Maybe this is a basketball. How much air fits inside? Measure in cubic centimeters, maybe something like that. So this one is pi r cubed. Okay. The only difference for that one is you have to add a little bit more to it than this. Okay, so the volume of a sphere has a little bit of difference to it. There's also this number here in front, 4/3. Remember, that's just all that is a division problem. 4 divided by 3 times pi times r cubed. And those are your two equations. Okay, and that's it. So we're gonna maybe do some practice problems applying this. For example, you might have to find like a hemisphere. Oh, that's like the worst hemisphere I've ever done. Sorry. Okay, hemisphere would be just the volume cut in half or the surface area cut in half. Okay, same thing. So what I'm going to do here is we're going to do, this is such a bad picture of it, I'm going to do it again. We're going to do a cone, but we're not going to do just any cone. We are going to do an ice cream cone. It's still not a very good sphere. I'm sorry, guys. So what I would like for you to find is the volume of this figure here. Okay, and I'm going to tell you the radius is 4 centimeters. Not a big cone, kind of a small, like a kid's cone. And the height, I'm also going to tell you that, of your cone is 10 centimeters. All right. So what I would like you to try to do is to find the volume of this figure. Go ahead and press pause and try it on your own. All right, let's see how you guys did. Let's start with the cone, because this is really two pieces and we're going to add them together. So the cone part is right here. We're going to add that up, plus the half circle, or the half sphere rather. Okay, they're going to have the same radius as well. All right, so let's go ahead and do this. Let's do the math on it. Okay, remember the volume of a cone is just the area of the base, which is the circle, times the height, which is 10, times 1/3, because it's not a whole cylinder. Okay, so go ahead and write that out again. 1/3 times the area of the base, which is going to be 4 squared times pi times the height. We can go ahead and plug this all in. 4 squared is 16, so 16 pi times 10. That's 160 pi times 1/3. And that you can honestly type into your calculator, even with the fraction. Though I would recommend, if you do use your fraction, it's a division problem, so tell your calculator it's a division problem. Put it in parentheses and do 1 divided by 3. Do not do 0.3. It is not a good approximation. You will get the answers wrong, and I will mark them wrong on a test. You just type them all in there. Okay, so we got 167.56. Okay. I'll just make it 5/5. Okay. Now let's do the area of this half sphere. Remember, that is 4/3 pi times the radius cubed. So we're just going to go ahead and plug it in. 4 to the 3rd power, if you use your calculator, is 64. So this is 4/3 times pi times 64. Okay, and what might be helpful for you guys is to write these formulas out each time. Okay, and again, draw pictures. If you're struggling with these and you don't have a picture anywhere on your paper, I don't know how you're able to solve these. They get really challenging. Okay, So, and again, we're just going to type that in the calculator, and we're going to use the fraction button. 4 divided by 3 times pi times 64. Plug it all in, and you have 268. Okay, and then all we have to do at this point is add all that up. 268.08 plus 167.55, and you end up with 435.6 cubic centimeters. More than you thought. It's a lot of ice cream. Okay, that's a half liter of ice cream. Nice. Because remember, 1,000 cubic centimeters is a liter, so it's actually more ice cream than you thought. Looks like a kid's cone. It's actually not. Okay, let's do one more practice problem, and I'm going to set you free on your homework. This one's going to be a little bit more challenging. So I want you to imagine a cube. Okay, so a cube is going to be like a square, but it's three-dimensional. So all the side lengths are the same. And inside is a sphere. Okay, and the sphere the edges are just touching all the sides. Okay? So the bottom, the top, I'll do the back here. Oops, there we go. So there's your picture, and I'm only going to tell you one dimension. I'm going to tell you the length of one side of the cube. One side of the cube is 10 centimeters. Okay? What I would like you to find is not the area of the cube, not the area of the sphere, but the area between them. Okay? That's the question. What is the area between the sphere and the cube? What's the empty space in this box? So think if you were to buy a box with a basketball in it. How much empty space is in your box? Okay? So go ahead and press pause and try this one as well. Really would recommend you try it. I know there'll be some questions like this on the test. Okay. Welcome back. I hope that that was not too bad for you guys. But essentially we have the following. Again, I love these diagrams. If you're not drawing diagrams, draw some bloody diagrams. Sorry, any Mr. Warren students. That's probably really offensive for me to say that word. I apologize. Bloody. So I have a cube minus a sphere is going to be the area in between. That's what I'm looking for. So because I'm looking for the space between them. So the cube is going to be the area of the base times the height. The area of the base is going to be 10 times 10. So 100 times the height, which is also 10. Okay? Because it's a cube, so everything's the same. So this is 1,000 cubic centimeters of possible space in that box. The sphere, remember the equation for the sphere, the volume is 4/3 pi r cubed. And this is a little tricky to find the radius, but remember the distance is all these sides are touching, so that means that halfway across the circle, I should probably use a different color here. Halfway across the circle here is the radius, so which means half of 10 is the radius on this problem. So it's going to be 4/3 times pi times 5 cubed. Again, you can go ahead and check your calculator on this one, but we can just type this in. 4/3 pi times 5 cubed, which is 125. And I don't even know what that is off the top of my head. And if I did, probably should be doing something other than teaching geometry. So that's 523. So I have 1,000. Let's just do it again. 1000 minus 123, or sorry, 523.6, which is going to leave you with the area between, which is 476.4. I find this kind of a surprising result, to be honest with you, and it's cubic centimeters. Remember, all of our units are going to be cubed when you talk about volume. Because when you see a basketball inside of a box, it doesn't look like there's that much empty space, but there's actually a lot in this situation. It's almost as big as the sphere itself. A little bit less, but not that much. Okay. If you have questions, go ahead and send me emails. I know those of you who have asked for help on homework have gotten a quick answer from me, and I've done a couple of live streams as well for those who are really struggling. So please just don't be afraid to schedule that stuff with me. My schedule is sort of variable, but when my wife is not working at the hospital, that means she can watch Luke, and I can be pretty available, particularly during class time on those days. So hope you guys have a great one, and I will see you on Monday.